Hey everyone, and welcome to my channel. My name is Kriti and I'm a data scientist. Today's video, I want to share my approach to how I solved a lead code problem. This problem is called the department top 3 salaries and it has a difficulty rating of hard. A lot of you reached out to me asking about lead code and if it's good enough for SQL practice. And to be honest, I hadn't used lead code previously. So I just wanted to kind of check it out for myself before I could actually recommend or provide my feedback or review on that. After having solved like a couple of problems, I can say that lead code is definitely a good platform to practice SQL on. So my motivation for making this video is to help you understand my approach to solving problems like this, and I hope you'll be able to take some of those lessons away and apply it to solving similar problems. Now this video by no means is meant to scare you in any way. You are absolutely not required to get the right answer at the first go or even just by watching this video. I must say that it has taken me a considerable amount of experience to be able to solve this kind of problem in a short period of time. So I do hope that me sharing my approach will help you simplify the problem and tackle it with confidence rather than, it being a benchmark for you to compare your performance against. So with that, let's get right into it. Okay, so here we have the problem on the left. I've included the details in the description below. Before we begin, what I first like to do is I want to create a template or a framework for myself before writing any query. I know that I need to select, and I know I need to select from employee. So I'm just going to write that down here, and it just makes me feel like I'm actually making progress in writing this query. The next step is to just fill in the blanks. The next step, just looking at the problem, I know that all the information that I want is not in the employee table. So I do know that I need to reference the department table as well. So I'm going to use an inner join for this purpose. And I know that this is an inner join because data is present in both the tables. Usually we use left join, outer join, or right join when we're unsure if the second table has all the information that's contained in the first table. Okay, so then let me just go ahead and fill in the name of the department table here. You see our template is now growing. Next, I'm going to give the employee and department table their own aliases. Now we use alias because we don't want to use the entire name of the table each time. So we just give it a short temporary name, and it's easier to kind of refer to the columns using these aliases than typing out the whole table name every time. Okay, next up, now that we have the inner join statement, we need to specify the column on which we would like to join the two tables. And just by looking at the structure of the tables here on the left, I know that department ID is something that connects the two tables. So I'm just going to specify department ID here along with the alias. And we need to use the alias because in cases where the column names are the same, for example, ID in department table versus ID in employee table, if we don't qualify it with the alias, then we're going to run into errors which say that there's an ambiguous column name. That is, SQL doesn't know which column you're referring to, if you're referring to the column from the department table or the employee table. Okay, so far so good. So we have our select statement, from statement, and we've also written the inner join. I think this already simplifies the problem. So let's move on to the next step. The next step is to specify the columns that you want to select. Just looking at the sample output, I know that we are looking at department, employee, and salary. So I'm just going to write that down here. Now, department is not directly called department in the department table, so we are going to have to select the name from the department table and then alias it as department. Similarly, we have name as employee as well as salary is just salary. There is no ambiguity in that, but I'm just going to include the alias here just for the sake of uniformity. Okay, so this looks good. Let me add a semicolon and just run that. So in a real environment, you would be able to see the result of this query. So usually I like to break it down in steps and check how my query is doing at each stage before I move on to the next. So I think our query syntax is correct because it's run, but we are not quite getting the output that we want right now. So this would form the base query off of which we'll be building other logic. So ideally you would want to store the results from this query in a temporary table. Now we can't quite do that here. So what I'm going to do is I'm going to use the concept of common table expressions. This essentially provides a way for us to store the results of a query temporarily, and the syntax for this is written as with T1. T1 is the name of the temporary result set. You can name it whatever you want. With T1 as, and you put this query in the brackets. So the result of this query is going to be stored temporarily in the variable T1. Now, if you're not too familiar with this concept, that's totally fine. I'm going to show you another way you can do this using nested queries that don't quite involve the common table expression. So the logic behind why we're storing this in a temporary table is because we've looked at the output and we know that essentially this is what we want. It's just that we're missing the top three component of it. So the next step is to just build the top three salaries component over this base query. The next step is that once we have this temporary table, we want to be able to select from it again. So I'm going to lay down the same template as we did before. This time I'm just going to say select from T1 because T1 is our variable which is going to hold the temporary result set. Alright, so now comes the tricky part. Now we want to select from this table only the department's top three salaries. So how do we do that? For this we need an SQL window function called as rank or dense rank. There's actually different types of ranking functions including row number and percentile, but for this purpose it's enough if you know like rank as well as dense rank. And I encourage you to read up the difference between these two functions. They are super handy to know, especially when you're trying to sort um, and kind of rank the records. I've linked the webpage I referenced below. The definition of the two functions is very clear, and for our purpose we're going to use dense rank because we kind of want to preserve two employees who may have the same salary. So we're going to use the dense rank because it does not skip any ranks in case there is a tie. Okay, so just going off of the syntax for dense rank here, I'm just going to move it to the next line. Now we know that while ranking, we want it to be sorted in the descending order of salary to be able to pick the top three highest. So let's just write that down here. We want to order by salary in the descending order. But that's not enough. Because we need it by each department, we need to specify the partition, which is the department. Essentially, what this would do is for every department, it would rank the salaries in the descending order. So we have our base query, and now we've built the logic to kind of rank the salaries by department. So the next step coming back, we're just going to select from this temporary table what we need in the output. Now I just realized I've made a mistake here in specifying the wrong alias for the dense rank function. We want to select the salary separate and keep the rank output separate. The rank would just be a number like 1, 2, 3. So I'm just going to alias that as rank underscore. Now I'm just going to specify the 3 columns that I need in the output and exclude rank from it because we don't want to display that. Okay, so before we get into further details, the next step of the logic would just be to filter the top 3, correct? So we use the rank generated in this temporary result set to kind of filter out only the top 3. So we want rank 1, 2, and 3 and nothing below that. So we're going to add this filter outside this temporary result set. that we're selecting from. So I'm going to mention where rank less than or equal to 3, and this is just going to give me the top 3 salaries by department. Alright, let me replace the star with the specific column names. We have department, employee, and salary, which was stored in T1. And then let me just run this code and see what we get. Okay, so there seems to be some kind of error in this code. Let's take a second look. Just realized I missed a comma after salary. So let's run this again. And there we have it. The solution is accepted, and yeah, I think it matches the output that was expected of this question. The time taken was 1691 milliseconds, faster than 42%. Not too bad. So let's look at the other way we can actually write this without using CTE. That is common table expressions, and see if there is actually a difference in the execution time. What we're going to do is we're going to retain the same logic. It's just going to be structured differently. So we're going to remove the temporary table and instead nest this query within the other query. So let's see how that looks. What I'm going to do is I'm just going to bring the final select statement on top and put this temporary result set that we had previously in its from statement. So it's the same thing, it's just different ways of writing it. I'm going to comment out the stop portion so that does not run, or just remove it, and then we can run this piece of code and see. Okay, so the result is accepted, and the execution time is 1263 milliseconds. Okay, so this one is definitely better than using common table expressions. So let's just stick with using the nested query. And there we have it. So I hope you enjoyed this video and got some insight into how to tackle such problems. The best practice is to obviously modularize your code, that is to break it down into chunks and then bring them together. If you found this video useful, do subscribe to my channel and give it a thumbs up. If you have any questions, let me know in the comments below. Also, make sure to check out my channel for SQL tutorials starting right from the basics. And that's a wrap. I will see you around. Bye now.